A student plans a series of chemical tests to confirm the identities of 4 organic liquids. I've been given the structures of those liquids here. We can see that J is both a carboxylic acid at the end there and a secondary alcohol. And we can see that K is a ketone and an alkene. And the L has a carboxylic acid at the left-hand side and a tertiary, this C has got 3 C's attached, alcohol, and the M is an aldehyde. This is a student's method. To separate test tubes containing samples of each liquid, add potassium dichromate 6 and warm gently. Then in test 2, add failings in ice water. Test 3, add sodium hydrogen carbonate and test any gas produced with a lighted splint. Test 4, add bromine water and shake at room temperature. So without reading on, there's definitely some issues with this method. Test 1, dichromate is a test for primary, secondary alcohols, but it also goes orange to green for aldehydes. But it's missing, it needs to be acidified potassium dichromate, and we acidify it with sulfuric acid. Add failing solution. Failings is a test for aldehydes only, gives a brick red precipitate, but you don't cool it, you need to warm it. Sodium hydrogen carbonate is a test for carboxylic acids, so it's a test for acids. But we wouldn't test the gases with a lighted splint because that's a test for hydrogen. We'd test with lime water because we want to test for carbon dioxide. Bromine water and shake at room temperature is a test for an alkene, and that test looks okay. So the first thing says identify the missing reagent in test 1. So we need to acidify our potassium dichromate or sodium dichromate, and we do that with dilute sulfuric acid. In addition to the missing test reagent in 1, there is a mistake in the method of 2 of the other tests. So we said we should be warming failings. So it says ice, what were the words exactly? It said iced water in test 2. Failings solution should be warmed, not cooled. And the mistake 2 was test gas with a lighted splint in test 3. That was a mistake. The gas should be bubbled into lime water to test to see if it's carbon dioxide. The missing reagent is added and the mistakes are corrected. Identify the liquid J, K, L and M that would react in each test and state the expected observation. So let's go back. Test 1 was a test for primary or secondary alcohols and aldehydes. So we can see that that's J and M. We've got a secondary alcohol in J and an aldehyde in M. A lot of students often miss out the aldehyde, but remember that they can be oxidised by acidified potassium dichromate as well. And our orange solution of acidified potassium dichromate will turn green. Now, failings was our test 2, and that was a test for an aldehyde, so that would only work on M. And a brick red precipitate is seen. Test 3 was to add the carbonate. We would see effervescence and then the lime water would go cloudy when we corrected that test. And we were looking for the 2 that were carboxylic acids. We scroll back, That was J and L. Effervescence for the carboxylic acid, and lime water turns cloudy or milky or white precipitate. And then the one that was an alkene, if we go back again and just check out, the alkene was the second one, K. And the bromine water is decolorized, or it goes from orange to colourless. Figure 10 shows the apparatus used to separate a mixture of liquids K and M using fractional distillation. Suggest labels that should be added in positions S, T and U in the diagram, and explain why fractional distillation is preferred to simple distillation for K and M. So we just go back and have a look at K and M. K is a ketone and an alkene, and M is an aldehyde. So they are similar functional groups. They're likely to have very similar boiling points, which is why we would use fractional distillation. S is pointing to our fractionating column filled with beads. That's improving the separation of things with similar boiling points. T is pointing to where the water would come out, and U is pointing to where the water would go in. So we said that we would use a fractionating column because liquids K and M are likely, aldehyde and ketone, to have similar boiling points, which makes simple distillation maybe not as able to separate them as effectively.